we do at the end, we'll kind of go through and look at some of the properties, but you guys have seen those properties every year for the last, I'm not sure how many years. So, algebraic proofs are is we're justifying each step that we do. Okay? So they're going to give you a statement, given the equation, 4x minus 1 equals 27, we're going to prove that x equals 7. Okay? So the first step is always to write out the equation that they give you and write given. Okay? Step 2, how did they get from 4x minus 1 equals 27 to 4x equals 28? They added 1. So all you have to write over here is addition. Boom. Okay, so then how did they get from 4x equals 28 to x equals 7? So we're going to write division. Boom. Okay, we're not going to do all these. I'm not going to bore you with all day long of going through a whole bunch of these, but we are going to go a few of them. So let's jump down to number 4. And the equation was 6x plus 7 equals 8x minus 17. So they wrote that and put given. The next one, they have 7 equals 2x minus 17. What did they do? They subtracted what? 6x. Yep, so we just have to write subtraction. Okay, then they went to 24 equals 2x. What did they do? How did they get from 7 equals 2x minus 17 to 24 equals 2x? They added that 17, yep. On that one, they did addition. Alright, now they've got 24 equals 2x, 12 equals x. What did they do? Division, I thought I heard an addition. They divided, put division, and now here's the deal. They don't like to write it as 12 equals x. They like to flip it. If all we do is flip-flop the sides, it is called reflexive. Because we're talking about the reflexive property. Alright, so they kind of helped us out with those, right? Now we've got to do it. What's my equation? 3x plus 1 equals 3x plus 1 equals negative 14. What am I going to write? Given. Alright, so what's my first step to solving this? We got to subtract 1. So over here, we're going to write subtraction, and if I subtract 1, I get 3x equals negative 15. Then what am I going to do? We're going to divide. So division, and now this is why they give you an extra little deal, because we technically x equals negative 15 over 3. My last step is going to be simplify. X equals negative 5. Who remembers doing these last year? Most of us? Okay, so all we did there was simplify. Okay, jump down to number 3. What's my equation? Am I going too fast? Do I need to slow down? Alright. What's my equation? L over negative 3 plus 10 equals negative 1. That was given. Then what do? Subtraction. m over -3 equals -11. Then what? Yeah, we're going to multiply. We've got m equals 33. You don't even have to use that last line in this one. Okay, one more. We got a whole bunch of stuff going on in this equation. Number 8. Alright, so my equation, 14 minus 2 times x plus 8 equals 5x minus 3x minus 34. That is given. What's the first thing I need to do? Okay, but what's it called when what I'm doing in parentheses? Distribute, yeah. Over here we're writing distribute. So I have 14 minus what? 2x minus 16 equals 5x. Remember, this is like an imaginary -1 minus 3x. There you go, plus 34. Very good. Then what do I have to do? Combine like terms. Yep. Over here, we just write combine like terms. So I get -2 minus 2x. So I've got to combine this with this equals 34. Yep. All right, what do you want to do next? There's two different steps we can do next. What are we going to add? Add the 2 over there. All right. Plus 2, we're doing addition. So I've got -2x equals 2x plus 36. Okay, so then we'll subtract minus that 2x. So -4x equals 36. Last step. Division. X equals -9. Could I have, we're not supposed to, could I have flip-flopped these two steps? Yes. Okay. The addition and the subtraction could have been flip-flopped. All right, little review of our properties. I'll let you work. What did I just call it if I flip-flop that order? Reflexive, so that's G. Two x equals 14 and x equals 7. Division, which is how about 4 equals 4? Symmetric, yep. And number 4? Yeah, we added 1. If 10 equals 2b and 2b equals c, then 10a equals c. Yeah, all they did was substitute. Okay, they took 2b equals c, and where they had 2b, they just put a c there. So they substituted c in for 2b. Good job. Okay, what'd they do in 6? Distribute, yep, e. What'd they do in 7? Didn't they just minus the 3 on both sides? Yeah, so that all that is subtraction. All they did was put a minus 3 on each side. How about 8? Nobody? Substitution. All they did was substitute. It said W equals 1. So this said W, they put a 1 in there. Substitution. How about 9? Multiplication. 10? Yeah, you know what? This could be substitution or transitive. Either one. Because they did just substitute it in, but when they're giving us 2, I screwed that up on the first one that we did. That can also be transitive. Either one I would take. How about 11? What are they doing both sides? They're dividing each other already? Oh, addition. Yeah, all they did was add the 4 right there. Addition. They added the 4 both sides. How about 12? Reflexive. Yep, all they did was flip-flop sides. Okay, a couple more and then I'll let you work. How about 13? Substitution, yep. Getting better with that one, Ed. What did they do in number 14? Yeah, they multiplied both sides by 8. So that one is C. H is what? Oh, sorry. Symmetric, yeah. And 16? It's like the distributive property backwards, which would be division. I'd probably go with division on that one. That's an odd one. Odd one, I say. All right.